Okay, so now when we look at photoelectric effect, what are my expected definitions? All right, we must be able to define all the following: photoelectric effect itself, the process of ejecting electrons from the surface of a metal when light of suitable frequency shines on them. What type of energy conversion takes place? This is not a common question. We are converting light energy to electrical energy because photo talks about light, electric talks about electrical. So it is light energy to electrical energy. It's a very important concept that you must know. Now the remaining are definitions. What is a photon? A photon is a packet of energy or a quantum of energy. All right, so it contains lots of energy. That's what we mean. Okay, then we have threshold frequency. I should actually quickly add to this. Let me quickly add to this. Number 7, I should add emission and absorption spectrum. Okay, those are important things that we need to know. Absorption and emission spectrum. Okay, there we go. Absorption and emission spectrum. Remember, all of these are definitions that we need to know going in for photoelectric exam. All right, so you must be able to define a photon as a packet of energy, be able to define threshold frequency as the minimum frequency of light needed to eject an electron from the surface of a metal. Work function is the minimum energy required to eject an electron from the surface of a metal. Now, what property of light is being described here? It is the particle nature of light. Very important. What particle? It is the what property? It is the particle nature of light. It is the particle nature of light. That is very, very important. All right. Absorption and emission spectrum, I'll explain that as we go on. I hope these expected definitions are important. All right. Now, quickly, let's go look at questions, all right, and look at how to calculate, look at the whole concept quickly so that we can then run through this as fast as we can. Okay, just allowing people in as fast as so. All right, I'll keep allowing as we go. Here is my first question. An experiment is conducted to investigate the relationship. Please, you got to read, all right, and get enough information from this story here. Just a second, I need to just invite some people. All right, so please read. It is the relationship between the frequency of light on a metal and the maximum kinetic energy. That's very important because once you get that corrected, you're good. All right? One of them is definitely going to be an independent, and we know that our independent is always on the x index. Independent on the x. Definitely our dependent variable would be on the y. All right, I'm going back to read, and I want us to get a few more concepts from here. It says an experiment is conducted to investigate the relationship between the frequency of light on a metal cathode. It means I am not changing the metal cathode. So I am changing the frequency, but the metal cathode remains the same, and I'm watching the maximum kinetic energy. Once we mention the metal cathode, we are actually talking about work function being constant. So work function is my constant what? Variable. So take note of how we have quickly interpreted a lot of information from just reading. Very important. And for those of you that have been with me, you know that we have done a lot on this graph. I'm just quickly going to guide you through. Here, my gradient is H. How do I quickly know? This is what I'm quickly going to check. E equals to HF. That is my frequency. That will serve as my gradient. All right. Number 2, that is my threshold frequency. That is my threshold frequency, and this is my work function. So properties that we must know on this graph as you try to attempt the question. We cannot play with those properties. They are very, very important. Okay, so we have done all of that. We have done all of that, and now we need to just answer the question. For this investigation, write down the following. Write down the following. Controlled variable. We talked about that. That is work function. Dependent, the frequency of light. So you see, we got all of that even before we started. Frequency of light. Name the phenomenon on which this experiment is based. It is photoelectric effect. Define the term work function in words. I'm sure we can all do that. It is the minimum energy required to eject an electron from the surface of a metal. That's not my concern for this. Now, first question says, calculate the value of x as shown on the graph. Let's go look at the value of x. We have already identified x as our work function. So we do not know work function. What do we know? Look, we know threshold frequency. That point is my threshold frequency. And you would see it is in the middle of 1,5 and 2. And if we add the 2 together and divide by 2 to get the midpoint, I'm sure we would get 1,75. That's going to be the middle. I hope you understand. How did I get my 1,75? I said 1,5 plus 2. It's the middle divided by 2. So already, let's make a list of the things that I have. I am looking for work function. Oh, what is the formula for work function? That's what I'm going to ask myself. What is the formula for work function? Let me change this. All right. I know work function is H. This is the first thing. Oh, seems like I know my threshold frequency from the graph. And I know my H. Done. 6,63 times 10 to the power negative 34 times 1,75. You remember that? Times 10 to the power. Okay, I don't remember the exponent. Let's just go back. And for those just joining in, you'll be able to see it as well. Times 10 to the power 15. I hope you see my 15 there. All right. Do you want to calculate for me as fast as you can? And it is work function. Our answer should be in joules. So you get your first 3 marks there in an exam. Very straightforward thing, guys. I need an answer. 1,16 times 10 to the power negative 18. All right, that's what you guys are giving me. 1,16 times 10 to the power negative 18 joules. I already have my 3 marks. Now, calculate the frequency of light, all right, that will emit electrons from the surface with a maximum speed. What is this? Speed, which is V. What are we looking for? We are looking for what? Frequency. Easy. We go to the main formula here, which we all know. What's our formula? E equals to what? Work function plus kinetic energy. But we are looking for frequency, remember. And I know here, that's my frequency. That's where my frequency is. I already know work function. They gave me velocity, so I have to break this down. Half mv squared. All we need to do is to substitute now. 6,63 times 10 to the power negative 33. I do not know the frequency, but I know my work function that we got. All right, plus half. The mass is the mass of an electron. You'll find it on your formula page. 9,11 times 10 to the power negative 31. All right, and we know the velocity. What is my velocity? 5235. 5,23 times 10 to the power 5. Please don't forget it is V squared. All right, this is so easy. We're just going to multiply. We're going to solve everything on the right and divide by 6,63 times 10 to the power negative 3. You do the maths for me and give me an answer quickly. Let's see your mathematics now. You said you're no maths. Let's see. Once you're done, you know, the faster you do it, the more we are able to talk about. I have 2 similar answers. 1,94 times 10 to the power negative 22. Kuto, you might just need to check your decimal.
So I think you substituted the exponent for h.
Oh, 34. All right. So is your answer correct?
No, usually the first going to be a different answer.
Please. Okay, guys, our answers are becoming very weird. Loniel, why 57?
No, you're giving the correct answers.
57.
But it's decimal 92.
Okay, but Lerato has 55 with 1,94.
No, because I changed the exponent to negative 34.
Okay, are you sure now it's 2,9?
Okay, so I'll double check.
Guys, did you square?
Yes, I squared it. Then
No, I mean your 5,23 times 10 to the power 5. You need, don't forget. I just feel that number 50 something is just too much. Yeah, no, Kuleko is giving me something that looks correct. 18. 50 something is just, I don't know. Please check again, everybody. Check again. One comma 16 times 10 to the power negative 18 plus 0,5 times 9,11 times 10 to the power negative 31 times 5,23 times 10 to the power 5 all squared. Alright, then whatever I get, I'm going to divide by 6,63 times 10 to the power negative 34. Yes, guys, please check. That exponent, 50-something exponent, is just extreme. Alright. Good. Please be careful on this particular, when you get to this particular section, we do normally have a lot of wrong answers based on calculation and how you put it in your calculator. So now we are talking, now everybody's on the same page. 1,94 times 10 to the power 15. Lovely.
Sorry, sir.
Yep.
So I'm getting a grade 1.9. So but my exponent is so 10 to the negative.
Okay, I wish I could see your calculator. Did you use the division line?
Oh, not Edison.
Yes. You see, that could be the problem, because your calculator would then multiply by times 10 to the power negative 34.
Oh, okay. Thank you, sir.
So please put it over the division line. Can you see my calculator?
Yes, I see.
Yes.
Okay. Thank you, sir.
All right, Linnell. Katie Bonnie, please fix it. Fix it. 1,94 times 10 to the power 15. All right, so please fix it and make sure we sort out these exponential errors. At least we know now what the error would be. Now, the last question will always refer to intensity. The intensity is now increased. State how this change will affect the current in the photocell. I've spoken about this severally, and I'm going to quickly do a crash course again. What does intensity refer to? Intensity refers to the number of photons. And what will happen? The number of photons only affects the number of electrons. All right? When there is photoelectric effect. So there must be photoelectric effect first before we talk about intensity. When there is photoelectric what? Effect. So I'm going to now say an increase in intensity, which is basically number of photons, will increase number of electrons. Therefore, current, or what you know as ammeter reading, will also what? Increase. Ammeter reading will also what? Increase. And I could quickly sketch graphs for you. Okay, by the way, let me quickly say something here. Please take note. Kinetic energy of electrons remains the same, because we are only talking about intensity. I'm going to sketch 3 graphs that the examiner can ask you. So examiner can put intensity here and number of electrons. Intensity, current in amps. Intensity, kinetic energy of electrons. All right, these ones are directly proportional. This one also directly proportional. This one is a straight line, because kinetic energy will remain the same. So please take note, this is in most cases the last question that is always thrown at us. I hope we are okay. Just before I go to the next question, I want to talk about something that runs side by side of intensity. So intensity is the number of photons, which affects number of electrons. All right. However, what about if I change the frequency, energy of light, energy of photon, How do I change the energy of photon? Remember, E equals to HF, or E equals to what? HC over. Okay, so to increase E, we use light of a higher frequency or shorter wavelength. I'm sure you still remember that. And this, you remember your infrared. You have infrared, and then you have your Röntgenbeam, and then you have your ultraviolet here. The ones on this side have very low energy. These ones have high energy. And if it has high energy, it means it has a high frequency and a short what? Wavelength. Here we have low frequency and a long. So you need to know how your energy increases. But what is the effect? All right. Increase in energy of the photon. Once I say E, you should know what it means. Will increase kinetic what? Energy of the electrons. But the number of electrons remain what? The same. And there's a question I like so much that I'm going to do. I think I hope I put it there. All right. So guys, this is it. Now let me quickly go look for, I think I do have a question, a very lovely question written from KZN. Okay. All right, let's look at this particular one. It says, in the diagram below, monochromatic light is incident. Monochromatic simply means light with single frequency. Right? Mono means one. Monochromatic light is incident on a metal plate, on a photocell. A sensitive ammeter is used to show a reading. All right. How will the energy of the photon of the incident light compare to the work function? Check this. They said a sensitive ammeter shows a reading. Oh, if it shows a reading, it means there is photoelectric effect. And what are the conditions for photoelectric effect? The energy of the light must be greater than the work function of the metal. The frequency of the light must be greater than the threshold frequency. The wavelength of the light must be less than the threshold what? Wavelength. Conditions for photoelectric effect. Very, very important. Conditions for photoelectric effect. Okay. Non-Jabulo, there you go. All right, I need to move forward, Non-Jabulo, quickly. I'm going to upload all yesterday's and today's. Once I'm done today, it's been very hectic for me today. So how does the energy of the photons of incident light compare to the work function? What would be your answer? You remember there is photoelectric effect because there is a reading. So what do you think? Do you think the energy of the photon is greater than the work function? Less than or equal to? Someone wants to say something to me. All right, answers are coming in now. Thank you so much. Now we're getting the whole idea. It has to be greater than. Give a reason for your answer. The ammeter shows a reading. All right. It is greater than because we are told that the ammeter shows a reading. It means there is photoelectric effect. All right. Once you do a calculation, okay, I'm just going to put it here. If kinetic energy is less than 0. If you do a calculation and you get kinetic energy less than 0, it means there are no photoelectrons released. There are no electrons released, which means there is no photoelectric effect. That's one of the ways to check if there is photoelectric effect. All right, look at this. When a change is made to the monochromatic light, the reading on the ammeter, increases, which means the number of electrons increases. Do you want to tell me? Okay, I want you to answer this. Elena makes the following statement with regards to this change. The increase in ammeter reading is due to an increase in the energy of the incident photons. Give a reason why this statement is incorrect. Bob, you can just unmute yourself. I just need one person to talk to me. Why do you think this is incorrect? Because Lena says the ammeter increased because of the increase in energy.
So, isn't it incorrect because only intensity increases the flow of electrons?
Yes, intensity will increase the number of photons, which only increases the number of electrons. I think I even just answered this question if you were following. It's on one of the slides where I spoke about intensity. So all the answers here, intensity talks about number of photons. Number will only affect number, and energy will affect what? Energy. Number of electrons emitted increases, not the kinetic energy. So take note, number will affect number, energy will affect energy. And what does the photoelectric effect tells us about the nature of light? I actually answered that when I was introducing the topic. Can somebody quickly tell me? What nature of light? No, not dual nature. You'd get it wrong if you say dual nature. We need to be, they said, what does photoelectric effect tells us about the nature? It is the particle nature. We know light has a dual nature, but this time around we're talking about photoelectric effect. Therefore, we talk about a particle nature of light. All right. Awesome. And that is ability to transfer energy and all of that. Okay, let's check this. Ultraviolet radiation is incident on the surface of a sodium metal. The threshold frequency, please take note of the things you are given. Once you start taking note of that, boom, you'll get your marks. The maximum speed, check that. This thing is so easy. So I have threshold and I have V. All right, define threshold frequency. We've done that. Calculate the work function. Oh, examiner says work function. Come on. 11.2.2. The first thing that comes to my mind is that. Do I have everything I need? Yes. 6,63 times 10 to the power negative 34. And my threshold frequency. Please take note of what you have. It will make life easy for you. Okay, let's save time. Just going to punch this quickly. 6,63 times 10 to the power negative 34 times 5,73 times 10. Please be careful when you punch. 3,798, which is 3,80. Remember, 2 decimal places. 3,80 times 10 to the power negative 19. And the unit, joules, 3 marks. All right. 11.2.3. Calculate the frequency of the incident photon. So I am looking for F. My F is hidden in E. Once you are able to say that, you are done. All right. So we know that E equals to what? work function, which we now have. Remember, they gave us V. Also, it's half mv squared. This is similar to what we did earlier on. HF, because we are looking for F. Alright, for time purpose now, I'm just going to skip this. Alright, I'm just going to put the values. We are looking for F. We do know our work function, 3,80 times 10 to the power negative 19 plus half. Remember, the mass of an electron is on your formula page. 9,11 times 10 to the power negative 31 times, please don't forget that this one is squared. 4,19 times 10 to the power 5, all squared. I'm sure you can get your frequency and your unit is in hertz. Very similar to the same one we did earlier on. All right. I hope that is okay. Done and dusted. Okay, let's look at this one again. I think this might be the last one or so. The simplified diagram below illustrates how a cathode emits electrons when light shines on it. All right. The incident light has an energy of 2,12 times 10 to the power negative 18. All right, joules. And the cathode has a threshold. Please take note of the things you are given. Take note of the things you are given. We are given the energy and we are given the threshold frequency. All right, let's go check something here. It says the incident light releases, I love this one, releases that number of electrons per second. So basically, we have the number of electrons. This is now a different ball game. We have n as 2,01 times 10 to the power 9 electrons per second. My time is 1 second. My time is 1 second. All right. Calculate the current. Look, guys, should you get something that shocks you like this in an exam, there is no need to worry. Go to what they are asking you to calculate, current. All right. What comes to your mind is electric circuits. But don't forget, we're talking about electrons, which are charges. I equals to what? Q delta T, right? Current is the rate. Do you remember that formula? Current is the rate Q over delta T. All right, I already know my time, 1. The question is, I don't know my Q. Q is the quantity of charge. So don't mistake, quantity and number are different. Now, if I use my electrostatics formula, so you need to go back to your electrostatics. All right? Guys, I want you to give me that formula. Everybody go check your formula page. There's a formula that has N, that has Q, and that has E, or somehow written as QE. Please go check for me. That's what I'm going to use. I want you to find it and see, because I don't have it on my page here. Quickly find it. I want you to find it so that you are accustomed to where it is. Beautiful, thank you. Yeah, now you see it. So, guys, you see that we are done. N equals to what? Q over E. I am looking for Q. Either you change your subject formula, it really doesn't matter. NE. Oh, I am looking for current. Beautiful. So I can therefore say I, what is my Q? NE over what? Delta T. I hope it makes sense. I hope it makes sense. Where N is the number of electrons. 2,01 times 10 to the power what? 9. And what is E? It is the charge on an electron. We don't need the negative this time. 1,6 times 10 to the power negative what? 19. All right? And over, my time is 1. Do you want to give me an answer here quickly? Want to give me an answer here? and that would be A. I hope you see the dynamics of how questions can be thrown at us. Waiting for an answer from you. Three comma 22 times 10 to the power negative 10. Thank you. Is it negative 10? Yes. All right. Learners from Cultura, I think we did this question when we had photoelectric effect class, so you didn't miss anything. All right, on this question. Okay, let's answer the rest of the questions now. The brightness. Now, they will always talk about this. Thank you, guys. Good answers. The brightness. Once you see the word brightness, they are referring to intensity. After this question, I'm going to talk about emission and absorption spectrum with you. All right. The intensity of the incident light is now decreased. Oh, okay. Please take note. They decreased it. What would that affect? It will affect the number of electrons and it will affect current. What effect will this change have on current? Will it increase, decrease, or remain the same? Do you want to give me an answer? Increase, decrease, or remain the same? Great, great. I see distinctions all around. It will decrease. Thank you. It will decrease. Give a reason for your answer. The number of photons, all right, has decreased. Hence, number of electrons also does what? Decreases. You would notice this section is always there. Now, calculate the maximum kinetic energy. Calculate the maximum kinetic what? Energy. We are looking for EK. Okay? The only place I'm going to get EK would be E equals to what? Work function plus kinetic energy. Let's go check. What are the things that we have? What are the things that we have? Let's go check quickly. What are the things that we have? Let's go back and check. Oh, first page, I think. All right, we have energy of 2,12 times 10 to the power negative 18. The incident light has an energy, 2,12 times 10 to the power negative 18. So we know that. 2,12 times 10 to the power negative 18. Do we know work function? We go back again. I'm just checking what we have. We don't have work function, but we have threshold frequency of what? 2,21 times 10 to the power 15. 2,21 times 10 to the power 15. All right, we know this is HF naught. So 2,21 times 10 to the power 15 multiplied by my H, 6,63 times 10 to the power negative 4. We are now looking for kinetic energy. I'm interested in your maths because of the exponent. Please give me an answer here. Thank you, Nompumelelo. Give me an answer here just to make sure that our exponents are in place. Give me your answers quickly. right? 6,55 times 10 to the power negative 19. Thank you. 6,55. Don't forget units, guys. 6,55 times 10 to the power negative 19 joules. We're talking about kinetic energy. Thank you, Nonkuleko. All right. Now, the cathode is replaced with another one, but with a higher. Look, I want you to learn to use your formula. Higher threshold frequency, but the same light. Wait, higher threshold. What will that do? Remember this. So with a higher threshold, I'm going to have a higher work function, which makes it more difficult for electrons to be released. How does this change affect the kinetic energy of photoelectrons released? What will be your answer? Do you think it will increase? Will it decrease? Will it remain the same? What will be your answer?
Increase.
Increase, decrease, or remain the same? How will this change affect the kinetic energy? Remember, we are increasing threshold frequency. I see that some of us are not so clear about what's going on.
Increase.
Legodi, what are you saying?
Decrease.
It will decrease. Guys, it cannot. Please read the question. Don't just. Some of you are used to writing increase. No. If the work function increase, look at the formula. E equals to work function plus kinetic energy. We are saying HF naught. So this value is increasing. What will happen to this value? It will decrease because E is constant. You can try numbers. Let's try numbers. 20 equals to 15 minus 5. We keep our 20 constant because the light, they said the same light. But now let's increase this 15 to 18. What do you think will happen to this number? This is how you do math and physics, guys. You apply. No, what am I doing now? This is supposed to be 25. All right, 25 minus 5. So if I then increase this number to, we increase in work function, right? My math is not, no, it's plus. That's what I was wondering. Why am I writing? Okay, let me do it again. 15 plus 5, 20. Now, if I increase this number to 18, what happens? Plus what? 3, because E is constant. So you can use things like this to quickly check how to answer. So I'm going to say, for the same light, which means constant E, an increase in F naught, which is that, okay, an increase in F naught increases the work function. All right? Hence, more energy is needed to eject an electron or to eject electrons from the surface of a metal. Resulting in low kinetic energy of photoelectrons. All right. Thank you, guys. Thank you. I see I was saying minus instead of plus. All right. I hope you understand. Please understand the whole dynamics of photoelectric effect. It is a place where you should get your mark. So we started looking at, we did graphs, all right? We did graphs, we did interpretation. Now I am quickly going to talk about blue shift. No, sorry, not blue shift. Absorption and emission spectrum. And that I'm not even going to waste time on it. All right. So it's a crash course. Absorption spectrum. All right. This occurs when light, and when I say light, I mean continuous spectrum, all right, passes through a cold medium. Passes through a cold medium. Your keyword is cold. Passes through a cold medium. All right. The electrons in the cold medium absorb photons and move to a higher energy level. Resulting in a spectrum of colorful background and black lines. This is the full story. Black lines. And the black lines simply indicate a missing photon. All right, absorption spectrum occurs when light, and when we talk about light, we talk about continuous spectrum. Like God is said, what happens if the value of E is not constant? And all right, that's going to deal with calculations, because E, as long as the light is remaining the same, all right. E talks about the light. We're using the same light. So if they change the light and they change the metal, you've got to do manual calculations now, because there's no ratio for those. There is no ratio for that. All right. So guys, please take note. We have cold medium. Electrons would gain what? Energy. And this is what we are going to be looking like. Energy levels. Electrons gain energy and they move from one level to the other. So you see the arrows are going up. E0, E1. This is an absorption. So think about it. Guys, think about that. When you receive money, your excitement goes up. Okay, so you are absorbing money. Okay, you are absorbing, therefore you go to the next level. That's when you feel like buying things that you don't even need. That's when you want to go to the mall. You know, some of you now, if you just get 1,000, tomorrow after exam, you just want to step into the mall. Just want to play. You want to enter into certain shops. When you don't have money, you just go by ShopRite. When you have money, you go to Edgar's. You know, even if you're not buying, there's just that feeling. You are excited. You are walking in air. Okay, you start a business. Ha ha ha. All right, but that is the whole idea. Yeah, you go to Woolworth. You see Jabulile says, "I'll buy food." You need to see that child. She likes eating. Okay, so that is you absorbing. Is that okay? Absorb. energy level goes up, it increases. So that is, and what do you see? Guys, you are going to see colorful background. I think I can quickly show you what it looks like. I can access my internet here and show you a picture, all right, of an absorption spectrum, because I wanted to see it. Absorption spectrum. When I say colorful lines and background, good. Okay. We should be able to get a very clear picture now. Okay, I don't need all their explanation. I can explain myself. I just need the image. All right, guys, I hope you can zoom in to see. I don't want to leave this page, you know. All right, they are all trying to explain what I can do. No, I can do my job, guys. Okay, there we go. I think if I do that, all right, I think there's one here. You can zoom out on your, okay, let me just, I'm lazy to do this, but I'm just going to do it. Okay. All right, let me quickly show you that image that I downloaded now so that you can have a good idea of what's going on. When I say colorful lines and it's pixelating. Oh gosh. All right, but I'm sure you can see. So you can see the one down. That's the one we're talking about, absorption. Colorful lines and black what? Background, black lines. Those black lines tell you that the photon responsible for that has been removed. And there was a time I actually did a demonstration for you guys, for those of you that I taught, I think if you remember. All right, that is my absorption spectrum. Now, what about emission spectrum? Emission spectrum. All right, a hot medium releases energy, emits energy in form of photons. It means the electrons move from a higher, and I want to show you a little tricky question they will ask you. Move from a higher energy level to a lower energy level. All right, so energy is lost in form of what? Photons. What do we see? We see observation. A black background with colorful lines. So it is the opposite. And this is what we have. Okay, that looks blackish. So energy levels are there. And what's happening? We are dropping from one level, a higher level, to another. All right. We are dropping from one level to another. This is E0, E1, E2, E3. So see the difference. We are losing energy. All right, guys, that's it. But here's the tricky thing that I quickly want to show you. Don't forget that E is directly proportional to F, and E is inversely proportional. The bigger the energy loss or gain, the bigger the frequency. So if you check this one, the energy of C is the biggest, which means it has the highest what? Frequency. They will ask you this. And then it has the shortest what? Wavelength. I hope you see. E of C is the highest. It's the biggest energy there. Energy difference. Alright? And sometimes there are calculations on this. If you want to get the energy of C, we're just going to say E3 minus E0. The energy of A would be what? E3 minus E2. The energy of B would be E2 minus E0. I hope you see that from the start to the bottom. And that is also used to measure the frequency and the wavelength. Guys, I hope you are good from the beginning to graphs and to absorption and emission spectrum. Okay. Please talk to me. I'm done with photoelectric effect. Did this make sense? I'm done with photoelectric effect.